Hello again, and today we're going to talk about Lindenmayer systems, or L systems, which is a sort of recursive grammar for producing fractal-like structures. This is the Wikipedia page with lots of information about L systems. You're welcome to look that up for yourself, give some examples of what they may look like, a lot of the history and the structure and such, and all that. Let's take just a couple look at some of these examples. There's a sort of a branch structure. There's this dragon curve here. There's this Sierpinski triangle and so forth. We'll let you look that up on your own, but we're going to go ahead and dive into working with Howler. I'm going to copy it from the archive into our place where Howler is installed, which is usually program files x86/Howler, or it might be in a Steam folder if you weren't running on Steam. And we'll press K on the keyboard in Howler to bring up the plugin panel, and there should be a L system plugin there, and there it is. All right, so as you can see, we have this simple interface, and I'm going to clear out some of this before we begin. I thought it would be good to discuss some of the parameters that are available to us. So here's the number of iterations. I'm going to start with an iteration of 1 so we can see what we're doing. We have a start X and a start Y. That's just the starting position where we're going to draw. There's a scale and an angle. All pretty common sense stuff. Now, say if we wanted to draw a fractal, we might create a Y or something like this. We draw forward, then we would draw kind of off to the left. Then we'd want to come back to here and then draw this way, and keep doing this recursively, and eventually we would end up with this kind of tree-like shape. So that's basically what we want to do with a drawing syntax. And L systems are basically based on a turtle drawing or turtle graphics, and there are a few simple commands available. So let's look at these. The drawing commands there's basically 5 of them. Plus means rotate right, minus means rotate left, and that's basically by a fixed value, which is specified in this thing here, 45 degrees, and you can change it to whatever you want. And then there's F or G for forward or go forward. You can use either one. They both do the same thing. And then the final commands are basically push and pop. They're the brackets, and the left bracket means save the transform state, and the right bracket means restore the transformation state. So to explain that, basically we'd use F to draw forward like this, then we'd save the transformation state, then we'd do minus to draw to the left and then draw forward. Then we'd want to restore, or right bracket, back to this area here and then draw forward, or actually we would rotate to the right and then draw forward. All right, so that's basically our turtle drawing and what we want to accomplish. So let's take a look again at that and do a simple formula. I'm going to start with the initial rule, which is X. X is a variable. We could go ahead and put our drawing commands in here, but I'm just going to go ahead and use a variable instead. And that variable will be replaced on each iteration. It'll be replaced by this area here. So let's put our function in here. We're going to do forward. Let's draw forward. And like we said, we're going to save the transformation, so that'll be left bracket. Then we're going to rotate to the left, which is minus. Then we're going to draw forward, F. Then we're going to restore the transformation, which is, right bracket. And we want to, let's actually see what we can do here. Okay, we're drawing that, but we need to zoom in on that some so we can see it. Okay, make it a little more. This is one iteration. What we've done is we've drawn forward, saved the transformation state, drawn forward again, and that's about it. Now let's draw a branch in the other direction. So we'll do the same thing we did before. We'll save the transformation state with left bracket. We'll draw, we'll rotate to the right, which is plus. Then we'll draw forward with F, and we'll restore the transformation state with the right bracket. Calculate that. Now we have a Y shape. Now that's great, but even if we did a number of iterations on this, 4 iterations, it still looks exactly the same. Well, that's because we're doing the same thing every time. We need to add into this grammar, this string of commands. We need to add into that a recursion. So we put a variable there. So I'm going to put the variable x here. And like we already said here, we're replacing this value x with what's here. In other words, we're replacing x with what's here. So if I put x here, it's going to be replaced by all that there, that f bracket minus f bracket bracket plus f bracket. And actually, it'll also replace recursively, put that in there. On each iteration, it'll put it in there once. So every time it meets this x, it'll put that in there again and again and again. So let's calculate that, and we see it. We've created this vine-like thing. But what we really want to do is, let's get rid of that. What we really want to do in this particular example is have these branches each appear at the ends of these other branches. So let's do that. We have to put an X at the end of each branch, one there and one there. And there you go. We've created this tree-like structure. I'll change the angle to 33, and you can see it looks more like a tree, or 22, and it's looking at more like a tree. So that is our first example. Now we can have a second variable in here. So I'm going to replace every time we find f in this string with ff. And this is going to make a more complex, probably a larger fractal, but a more complex fractal. And I'll have to change the scale so we can see it better. I'll change it to 1 and maybe 2. 2, so we can see it better. So we've created sort of a more interesting fractal at this point. So you can use a second variable as well. So, all right, let's go back to what we were doing. So we've created this tree structure. Well, what if we want to do some other things? Say we wanted to branch like even and odd. So let's take a look at how we can do that. We'll do a forward, then we'll branch to the left. Make sure we save that transformation state and restore it. We'll go forward, then we'll branch again to the right. Save the transformation state, or push, plus rotation, forward, and restore the transformation. Calculate that and see now we have this even odd branching. Now let's put that x back in there after each branch and calculate it, and we get a more recursive version of that. This is much more another way, really, of doing what we've been doing. Another thing we can do here is put an x at the end. Remember when we created that vine, we had the x at the end? Well, this will cause it to not only branch in each direction, but it'll cause it to keep going up. So let me show what I'm talking about. It'll cause it to keep growing upwards as well as branching. So that is another thing we can do there. So what if we wanted this to now curl off in a direction? We could actually replace f with f, or minus f. It will now rotate in a direction. Calculate, and we can do that same thing before we replace f with ff. So these are a few of the things you can do with L systems. This is the really basic things you can do with it, but I think it's a good start showing that anyways. So hope that's been interesting. Thanks for watching, and let us know what you think, and ta-ta for now.